in the next section of chapter 2, we're going to cover graphs of sine and cosine functions. Section 2.3, graphs of sine and cosine, is going to cover 3 separate videos, one for the general graphs. Then we're going to do 2.3.1, which is talks about amplitude and period. And then 2.3.2, which talks about phase shifts and vertical shifts of our graphs. So first thing we're going to do is to graph any function. If I put in x values, I get the corresponding y values. I plot those on an xy coordinate plane. One thing you'll notice about these xy coordinate planes is that the y's are using real numbers here. And then there are also real numbers on the x's, but instead of using 1, 2, 3, I'm using multiples of pi, because we know values of our sine and cosine functions based off of the unit circle definition for multiples of pi. 0 pi, the x coordinate is 1, the y coordinate is 0 on the unit circle, so the cosine of 0 pi would be 1, the sine of 0 pi would be 0. So as a reminder, if I have any point on the unit circle, the x coordinate is the cosine of the point, and the y coordinate is the sine of the point, okay? So what I'm doing is I'm putting in values of pi going around my unit circle, which are these radian angles coming here, and I'm getting out for the sine graph, I'm looking at what the y coordinate is on my unit circle, and then for the cosine graph, I'm going to look at what my x coordinate is on the unit circle. I'm going to do it at every 45 degrees, or pi fourths, okay? It makes it easy for us to do. At pi fourths, the x coordinate would be square root of 2 over 2, the y coordinate square root of 2 over 2, and square root of 2 over 2 is approximately 0.7071. So you notice I have a lot of 0.7071s, both positive and negative. I have dotted about 3/4 in the positive and negative direction in blue. My graph goes between -1 and 1, okay, for both x's and y values on the unit circle. So I'm going to go between -1 and 1 on the y values on my graphs. And that's the last thing I need to know. So in your first graph that they gave you, I actually have it plotted for you in the notes. So if I start out at negative pi, I'm doing the sine graph, so I'm just going to look at the y coordinates here. So negative pi starts out over here, so the y coordinate is -1. So the y coordinate at negative pi is -1. Then at -1, 2, 3 pi fourths is going to be -0.7071. Oops, I did something wrong here. This should be -1, 0. So let's start that again. First y coordinate is 0. This one was correct, negative square root of 2 over 2. Then -1. Then negative square root of 2 over 2. Then 0. Positive square root of 2 over 2. Positive 1. Root 2 over 2. 0. Okay? Notice that if I'm starting here at the origin, the sine graph starts at the origin going up every pi fourths increments for the standard graph of y equals sine theta. Okay? And once you get the pattern, just go this way, starting at 0. Once you get the pattern, you know where to put the rest of your dots. You don't have to keep going around the unit circle if you are careful. And then what we're going to do is we're going to combine these with a smooth curve. Okay, this is not a Charlie Brown t-shirt. These are curves. And my sine and cosine functions are both going to continue on forever in here, okay? So, quick point out is that the domain of the sine function is negative infinity to infinity, and the range is going to be from negative 1 to 1, inclusive. Okay, so that first graph is already drawn for you. We'll do the same thing for the cosine function. I'm going to start at 0 radians. Then I'm going to go in the positive direction and see where I start. Well, I go from 1 at pi fourths, I'm square root of 2 over 2. At pi halves, I'm at 0. 3 pi fourths, I'm negative root 2 over 2. At pi, I'm at negative 1. And now we see the pattern. It starts at the top, and it works down. So now I can just repeat that pattern carefully. Every even multiple of pi, I'm going to be at 1. Every odd multiple of pi, I should be at negative 1. At the odd multiples of pi halves, I should be at 0. And we connect them with a smooth curve. So that is the basic graph of the cosine function, and we have the basic graph of the sine function. Here's the, again, domain is all real numbers. And the range is from negative 1 to 1. So here's what I want you to remember about the sine and cosine graphs. Sine of theta, it starts at 0, going up. The cosine graph, it starts at 1, going down. Okay? Now, just like every other graph of every other function that we've had, if I put a negative in front of sine and want to graph negative sine of theta, it would just turn this graph upside down, reflected across the x-axis. Same thing if I put negative cosine theta, it would just reflect the graph across the x-axis. Okay? So remember, a negative in front of a function flips the graph upside down with basically reflection across the x-axis. Okay? Other things that we have seen before, and we saw this recently, that sine is an odd function because f of negative x is equal to negative f of x. Okay, and remember, an odd function is rotation of 180 degrees about the origin. Okay, so if I pick any value of x, okay, so I'm going to pick pi halves. So what this is saying is f of negative pi halves, which is negative 1, is the same thing as negative f of x, which is 1, and put a negative in front of it, which would be negative 1. So that's where that rotation, so if I were just to focus on this part of the graph, you can definitely see that it's a rotation of 180 degrees about the origin. Okay, an even function, that's when f of negative x is equal to f of x. That means it's reflected across the y-axis. Okay, so that means, let's pick pi. That means f of pi and f of negative pi are going to have the same value, and yes, we see that they do have the same y value of negative 1 here. Okay, so Sine is an odd function. Cosine is an even function. Okay. That is all for the basic graphs of sine and cosine. What I'd recommend doing is practicing graphing from negative pi to 3 pi for sine and cosine. Make sure that you can do it on your own. Make sure you understand where the numbers are coming from when you are doing it on your own. Okay, and again, this section is going to be broken up into 2 more videos. I'm going to pause this one and get set up for the next one.